Today we want to talk about the respiratory system, and particularly we want to start off with the process of breathing. This is known as ventilation. How does air get in and out of the lungs? So let's start off with a diagram and we'll have a think about it. So air gets into the lungs via one main airway, the trachea. And the trachea is held open by incomplete rings of cartilage, C-shaped rings of cartilage. And these go round the trachea to keep it patent, because it's absolutely vital that the patency of the trachea is maintained. If this is obstructed in any way, then you're going to asphyxiate. And this ties in very nicely with our clinical priorities, which are going to be airway, breathing, and circulation. This is the A for airway. Now, just above the trachea, there is another couple of interesting structures. Just here, there's an area called the larynx. And the larynx will contain the vocal cords. And the front part of the larynx is made of the thyroid cartilage. So you can feel that. In English we call that the Adam's apple. Rather strange expression, but that's what we call it. It's that knobbly bit in front of your neck, the thyroid cartilage on front of the cartilaginous larynx. And underneath that, there's another large cartilage, and that cartilage underneath the larynx there is called the cricoid cartilage. And this is unusual because the cricoid cartilage is a complete ring of cartilage, unlike the C-shaped rings of cartilage on the trachea. The trachea starts just underneath that cricoid cartilage, and between the thyroid cartilage of the larynx and that first cricoid cartilage, this area here is the cricothyroid ligament. The cricothyroid ligament. And you might learn at some stage how to make an opening into the cricothyroid ligament, as that's sometimes necessary, a cricothyroidotomy as an emergency airway. So we've got the larynx, the vocal cords, the cricothyroid ligament, cricoid cartilage, the trachea with its incomplete rings of cartilage. Now, the esophagus is immediately behind, immediately posterior to the trachea. So if we imagine that here's the C-shaped rings of cartilage on the trachea, and there's some connective tissue at the back there. Now, the esophagus is immediately posterior to the trachea, immediately behind the trachea, the esophagus or food pipe. So that's there with a relatively thick muscular wall. So when a bolus of food is going down the esophagus, we don't want it bumping over all these rings of cartilage. That's why the rings of cartilage are incomplete, because the bolus of food can easily distort the shape of the connective tissue, whereas the cartilage is rigid. But we see that there's enough section of cartilage here to maintain the patency of the trachea. Now, the trachea divides into the left and the right main bronchus. And of course, remember, this is the left side here, because you're looking at mine. So this is left over here. Now, this divides into two. Now, the right main bronchus tends to go straight down, like this, whereas the left main bronchus is more a divide off at that kind of angle. And this is important clinically, because this means when people inhale things, for example, you might get a child in who's inhaled a peanut, then it tends to go down the right main bronchus. Or if you're intubating someone and you intubate too deeply, it'll go into the right main bronchus rather than the left main bronchus, nearly always. So the right main bronchus carries on down here like this, and the left main bronchus is more a branch off to the side. So all of the air going to the left lung is going to go through the left main bronchus, sometimes called the primary bronchus, and all of the air going to the right lung is going to go through the right main bronchus, or the right primary bronchus. And these bronchial passages still have their rings of cartilage to keep them open. Rings of cartilage to keep the trachea patent and to keep the main airways patent and open. Now, the left lung is divided into two lobes. So this left main bronchus quickly divides into two smaller bronchial passages, still fairly large, still with their rings of cartilage. And these are called the lobar bronchi. The lobar bronchi, because one is going to each lobe, each one of the two lobes of the left lung. Whereas the right lung is actually in three lobes, so this is going to divide into three relatively quickly like this. The three right lobar bronchi. And these carry on dividing. The next level of division will be called segmental bronchi, breaking down into the segments of the lungs. So these carry on breaking down. And they will carry on breaking down many times. In fact, there's about 20 to 25 divisions, getting progressively smaller. And the effect of this is that if you turn the whole thing upside down, it looks a bit like a tree. So the trachea would be the main trunk of the tree, with the bronchial passages being the branches. And so we call this the bronchial tree, dividing into progressively smaller and smaller bronchial passages. I'm sure you've heard of the condition bronchitis. Itis means inflammation of. So inflammation of the bronchial passages, bronchitis. Quite common in people that have been exposed to smoky environments or have smoked. So the bronchial tree is taking air to all parts of the lung. And this diagram is much more clever than I've drawn it, or the reality is much more clever than I've drawn it, because the breakdown of the bronchial passages actually forms a fractile pattern. This is fractile, with each division mimicking the previous division in a fractile pattern. And that's important because it ensures the flow of air is equal to all parts of the bronchial tree. So this fractile pattern allows for equal admission of air to all parts of the bronchial tree. Now, this, as we've said, subdivides into smaller and smaller bronchial passages. The small bronchial passages are actually called bronchioles. But we'll look at those in more detail later. But for now, let's notice this bronchial tree is passing air, conducting the air. These are sometimes called conducting airways, down to the small bronchioles, the much smaller bronchial passages. But overall, these form the lung, and the lung is this kind of shape. It goes down a long way there, then up because of the diaphragm, and that would be the left lung. And as we've noted, the left lung is in two lobes, simply called the upper and the lower lobe. Now this is important because if someone gets infection in the lung, ideally we don't want the infection to spread throughout the lung if we can avoid it. And if there is infection in one lobe of the lung, sometimes that can be limited to one lobe of the lung, a condition called lobar pneumonia, particularly common in young adults. They're prone to lobar pneumonia. And the situation's similar in the right lung. Here, and the right lung, as we remember, is divided into three lobes, the three lobes of the right lung, and the fractile pattern of the bronchial tree taking air to all parts of the lung. Now, of course, the key thing is that we get air in and out of the lungs. So how does this occur? Well, surrounding the lungs, we have the ribs, and you have 12 pairs of ribs. Probably only got 10 there, but never mind. So there we have the ribs surrounding the lungs. And in between the ribs, we have the intercostal muscles. So when we're talking about costal, that means to do with ribs. So the muscles in between the ribs are the intercostal muscles. So I suspect you've probably all eaten barbecue spare ribs at some time. But the meat that you're eating off the ribs is actually the intercostal muscles. And there are two main sets of intercostal muscles. There's one set on the outside, between the ribs on the outside, like this. These intercostal muscles, the external intercostal muscles. And there is another set of intercostal muscles which are internal. But they're all connecting the rib above with the rib beneath. So the internal and the external intercostal muscles. And it's the same on the other side. External intercostal muscles and internal intercostal muscles, joining up the ribs. And these black areas, of course, are cross sections of the rib. So this will be a rib in cross section here, like that. So the ribs and the intercostal muscles are forming the thoracic wall, the chest wall. This is your chest wall here that you can feel on both sides. And we can see that on this mannequin over here. So here we see the thyroid cartilage that we were talking about. And that is the cricoid cartilage just there. And this gland surrounding it is the thyroid gland. And then we notice the clavicles, which are the collarbones. The bone at the front is the sternum. And then we have the ribs. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You actually have 12 pairs of ribs, but the bottom 2 are not connected to the sternum. And we notice this grey material in this model, which is the costal cartilage. So the ribs are connected to the sternum via these costal cartilages. And in this model it doesn't show the intercostal muscles, but we know that the intercostal muscles are between the ribs. This bit below is the liver, just below the right costal margin. And then if we take these front parts off, we can actually expose the cross sections of the lung underneath here. And here we see the position of the lungs on both sides relative to the heart. So the lungs within that thoracic cage. Now, at the bottom of the thoracic cavity, at the bottom here, dividing the thoracic cavity above from the abdominal cavity below, we have the large domed muscle, which is the diaphragm. So that's the large domed muscle of the diaphragm. And the diaphragm is muscle which is supplied by 2 nerves called the phrenic nerves, which move the diaphragm. And 75% of respiratory effort in normal resting breathing in your breathing at the moment is supplied by the diaphragm, and about 25% supplied by the ribs and the intercostal muscles. So that's the first section of this video. Next one we're going to look at, the second one in the series, is going to be how these structures move in order to generate inspiration and expiration.